In this video I'm going to produce a binary search. To be honest, it's really quick to do. In fact, the searching is quick, and really your result should also be fairly quick. But there's a lot of explanation that goes with it, and you don't need to write down everything that I write down. It sort of falls in logically, so I'm writing down more than you should. So see what you need and see what you don't. It won't hurt if you write down everything that I write down. Now, what a binary search does is, and the whole point is, it's binary. It splits a list into two parts. The two is the binary, and we can check whether a number is in either the bottom half or the top half of a list, and keep splitting that list in half each time. And it's really efficient. So for example, when we did the linear search, if we were looking for a number that wasn't in the list, we had to do, if it was 1,000,000 items long, we would have to do 1,000,000 comparisons, and that would take the computer a fair amount of time. However, with a binary search, if the number isn't in the list, because we're splitting it and looking at half a list each time, not exactly half the list, it could be one piece bigger than the other, but we are reducing the amount of numbers in the list each time, then if a number isn't in the list, we'll have a maximum of around about 20 comparisons, which is a great deal quicker. Take a look at what I did on the web page just to see how that works. So here's what we're doing. We're going to look for the value 31. Now, in the program that I wrote, I used the length of the list, because the computer programs, or the majority of computer programs, would just tell me how long this list was, and I could just find the midpoint in this list, which is right here, just by dividing by 2. So if the list was 1, 2, 3, 4, 5, 6, 7, 8 items long, divide that by 2, it's 4. Okay, so it's right in the middle. So let me show the indices for these. 0, 1, 2, 3, that's the 4, 5, 6, 7. So if you notice, the 4 is the actual index 4 is just a little bit above the arrow. So what I'm going to be doing with a calculation here is rounding up if I've got my number. So how's this going to work? I need to find the midpoint, and this is the important part of the equation. I need to take the first index, right index on the bottom there, so you know, and I'm going to add that to the last index. This is just finding an average if you really need to know, or the same way, and then I'm going to divide that result by 2. If it's sort of got a decimal ending after dividing by 2, I'm going to round up. Otherwise, I'm just going to keep the number that I've got. So let's start with this one here. So my first number, or first index, is 0, plus my last index, which is 7. So the midpoint in my list is, well, nothing plus 7 is 7, divided by 2, which equals 3.5. Because I've got a 0.5, I'm going to round that up to 4. So you can see that both ways, using the length or using this first and last, is going to give you the correct index to look at. And that index is the one that I'm going to check. So I'm actually looking at the moment at this one here, and I'm going to check that for my number. The first thing I'm going to do is check to see if it's equal, because if it's equal, then I found it. So I'm looking for 31. Does that equal 27? No, it doesn't. So I haven't found it. So I've got to work out which side of my list, and remember that although we can see it and know where it is, the computer wouldn't have a clue. So I'm going to work out which side of my list that number might exist in. and as you can see it's going to be in the right hand side of the list. So I'm going to say if 31, that's the number I'm looking for, is greater than the value in my list. So difficult to write. You could write the list with an index, but just pull out the value. If 31 is greater than 27, then I need the right half. The other thing, I wouldn't know at the moment, if 31 was less than whatever value was at position 4, then I'd need the left half to search for, because the value would be lower. In my program that I wrote, I actually took the value 27 and put it in my list. It really doesn't make much difference. But here we know that it wasn't equal to 27, and I'm going to take the right half, or the right portion of the list. So I'm going to take it from the next element on. So I'm just going to take 31, 42 and 45, and I'm going to index them the same, 0, 1 and 2. So I've ignored this. In my program that I gave you, I didn't ignore that. I put that in as well. So I repeat the process. I need to first find out what number I'm finding for or what index is going to be the midpoint. Quite clearly 1, we can see that here. If I did the length of the list and divided it by 2, well, the length is 3. Divide that by 2, it gives me 1.5. I could round down to get the 1. It's just the way you choose to do things. It's up to you whether you round up or round down. This method I'm rounding up, but this time I've got my start at 0 and I've got my last item in my list at 2. Nothing plus 2 is 2. If I divide that by 2, 2 divided by 2 is 1. That gives me a midpoint of 1, which is quite nice because actually there it is. I didn't need to round up and I've got my midpoint. So I'm going to do the same checking that I did over here. So here's my number. First of all, I'm going to check to see if 31 is equal. If it's equal, then I found it. Well, 31 and 42 are definitely not equal. And I'm only looking at this value here. So I'm going to have to move on. I do my next check. 31, is that greater than 42? No, so I'm not going to do the right hand. 31 less than 42? It certainly is, so I need the left hand portion of my array. And the left hand portion of my array, not taking the 42 with me, is 31. So I've now got a list of just one element, 31. And I can do the same thing again. My first one is 0, my last one is 0, that's 0, 0 divided by 2. Well, if you try that on a calculator, you're going to end up with 0. So now I'm checking at position 0. So run the same test. 31 is equal to whatever's at position 0. 31 it is. So I have found the item in the list. So quite difficult doing a binary search, or quite difficult explaining the binary search, but it really is pretty much straightforward. Let's just have probably make a mistake in this one, but let's have another look. The important part is the list must be ordered. So I'm going to use this list here. 1, 2, 3, 4, 7 and 8, and I'm going to look for 5. Now if this was a linear search, I'd need to do 1, 2, 3, 4, at least 5 comparisons. Let's see how this one pans out. So I need to find the middle element in my list. Well, it goes between these two. So I'm going to round it up and look at that one. So I didn't even need to do the maths on this. And this is how you should approach it on your exam paper. So you check to see if the two numbers are equal. They're not. So you split the list. As we've already checked this one, you don't need to bother. Just write down 7 and 8. That's my new list. We're going to check these two again. So let's find the midpoint. It's right there between them. So that means we could either round up or round down. I'm going to choose to round down and start looking at that element. Is 5 greater than that? So am I going to take the right hand side? No, 5 is less than. So I'm going to take the left hand side. But as I've already checked it against 7, I've really got an empty list now. And because I've got an empty list, no values in it, 5 doesn't exist in my list. Let's do that one again. 1, 2, 3, 4, 7 and 8. And this time we're going to look for 2. So check it out. Find the midpoint here. Let's round it up. Is 2 equal to 4? No, it isn't. 2 is less than 4, so I'm going to take this section of list. 1, 2, 3. Run it again. Find the midpoint of the list. It's 2 equal to 2. It is. I have found it. So it's really, really quick when you try going through it. Maybe you'll have 2 or 3 comparisons. You certainly won't have that many. Because it will find what you're looking for incredibly quickly. Unlikely that you'll be looking for something that doesn't exist in the list. They will give you a number that does exist in the list and expect you to see how you do it. The last one I'm going to do on this one, let me just check it out. Let's run that list again. But this time I want to find the value 1, so I've got a few more items in my list. So let's put that list in again. It was 1, 2, 3, 4, 7 and 8, and I'm looking for the value 1. Better if you could see it. So find my midpoint, which is here. So I'm going to round up, take that one. 1 is less than 4, so I'm looking in this half, so I need to write down my 1, 2, 3, and I'm just going to discard all this part of my list. Now again, I'm going to check and find the midpoint, which is 2. Check 1 against 2. Well, 1 is less than 2, so I'm going to need this side of the list, so that gives me 1. And I can discard that part of my list. And now I'm going to check this one. There's no midpoint. There's only one item. It's 1. I have found it. So that found it in 3 goes. So really, really quick. If you remember, we were looking at 5 goes to find if a number wasn't in the list. We're probably looking at 2 to 3 goes. So it's really, really quick, the binary search, but quite difficult to get your head around and write down a method. I haven't really found a decent method to write down, but as long as the exam board can see that you understand by your workings out, then you'll get the marks.